So, hello everyone, and welcome to yet another recreational programming session with Mr. Zozin. So, as you probably know, some time ago I looked into .NET infrastructure, right? So I looked into Microsoft.NET and also Mono and everything. And actually I looked into all of that for a very specific reason, right? So we are developing a compiler. So there's like 25 of us, right? So it's not my compiler, it's our compiler. Right, so and one of the targets that I want you to add is actually .NET target, right? So, and the reason why I want you to add it is for shits and giggles, right? So that's why I want you to add it. Right. So, and I think the time has come to actually at least introduce something, right? So I originally wanted to make a target that doesn't really depend on that much of external tooling, and this is, by the way, the reason why I looked into the format of .exe that contains the .NET bytecode and stuff like that. All of these streams I'm talking about, by the way, are going to be in the description, so don't worry about that. I'm going to pull an entire playlist in there. Right, so, but it's kind of like complex on its own, and I feel like if I'm going to be rat-holing about all of these .exe format and bytes codes, I will get nowhere. I should probably at least start with something. Let's implement a very dumb .NET target that just generates LD-ASM, right? So basically, is it LD? I don't remember. I think it's a not LD, ilasm, right? So Mono comes with this tool called ilasm. Il stands for intermediate language, asm for assembly, right? And what it does, it just like takes intermediate language assembly, right? And compiles it down to an executable that you can run with Mono interpreter or with the .NET interpreter and stuff like that. Not really interpreter, but the virtual machine, right? So as far as I know, it's a ahead of time compilation. It's not really interpreting anything. Right, so let's just like make a target that just generate that assembly and feeds that into ilasm. That way, we'll actually figure out what kind of problems we may encounter, right, while implementing a more self-contained target, right? And I'd like to also discover like how inflexible our intermediate representation currently is to accommodate targets like that. Right, because our intermediate representation is actually tailored specifically to our programming language and specific targets like x86-64, ARM, and also a bunch of toy targets like UXN and 6502. Well, you may argue that 6502 is not a toy target, but whatever. Right, so I just want to add another target, which is a virtual machine. So just to sort of extend the flexibility of our intermediate representation. Right. So to extend the flexibility of our intermediate representation. So what I'm going to start with, I'm probably going to start with just making Hello World compilable into .NET, right? And if we have enough time, maybe I'm going to add more different operations, right? So, but I think like the goal, at least the minimum is to make this Hello World compile. I think it's a pretty good target for today. Sounds good? Sounds Gucci, Tamaguchi. Let's fucking go. All right. So let me see. So I need to, remember how to even program in IL, right? Like what exactly do we have to output? Like I completely forgot. On the previous streams we already kind of explored that, but I want to explore that again. So let me see. Let me create it like a trash folder, and in a trash folder I'm gonna create like hello. Honestly, like I mean I didn't mean to say that C# is trash. It's just yet another boring language for enterprise. But it's just like this is something that I'm gonna throw away later. So console right line, and this is gonna be system, right? So let's actually do something like hello world. The business language. Yeah, it's a boring business language, just like Java, right? So for me, it is as shitty as Java, and I programmed in Java professionally. So, okay, so it's one of those languages. It's one of those languages. Anyways, so okay, let's try to compile this entire thing, and yeah. It did in fact compile, right? It did in fact compile. So Mono comes with a thing called monodiz nuts, and it allows you to actually to actually generate ilasm. This is an il assembly, and we can actually save it to something like this, right? So it created this file, and it created a lot of garbage in here, right? So, and the part that we're interested in is this one. Right, so this is the entry point, and this is basically bytecode. So .NET or CLI or whatever is actually stack-based virtual machine. So as you can see in here, we're pushing a string onto the stack. We're pushing the string onto the stack, and we're calling write line. But specifically, we're calling it like the string version of it, because as far as I know, this particular thing is overloaded, right? So there's different versions, and depending on the version that you want, you have to specify the type in here, and it's a part of the binary format as well. So as far as I know, there's a lot of things in here. For example, for printing unsigned integers and stuff like that, right? Specifically, we're calling the string in here. So there's also nop operation and just return out of this entire thing. So the cool thing is that now I can recompile with ilasm this entire thing back. Right, I recompiled it back. So I can try to run it with a mono runtime. It says hello world, but it doesn't really confirm that it is the modified version. So let's actually go ahead and modify it, and I'm going to run it one more time. As you can see, it's actually modified. So I can now program directly in assembly, and it's going to work. So the problem here with this specific executable is that the executable produced by monocompiler, like, it's not compatible with the Microsoft runtime, right? If I try to do something like .NET run .exe, right, it will tell me that like it cannot do that. Well, I mean, you have to not really do run, but just like this. So it cannot run it. It wants this some libhost policy.so or something like that. But off screen, I was actually experimenting with this kind of stuff with the mono executables. And the thing you have to do, you have to like add this runtime config JSON. Right, so it really wants this runtime config JSON for that executable. So without it, it cannot run it. Mono can run it, by the way. Mono can run it, but .NET for Microsoft, it's incapable of running it. So let's actually just create like an empty one. Right, so JSON parsing error or whatever. Right, so the document is empty. It has to contain at least something. Right, so, and it wants like a very specific stuff in there. Right, so we try to Google it up. So config options, there was some article in here that describes what exactly is expected. Yeah, there we go. So something like that, right? It's basically a parameters, right? Which is honestly, if you think about it, kind of a five-head move, right? In the sense that how many times you had to run a Java applications with enormous amount of flags, right? Especially if you want to run Minecraft with these specific optimizations and stuff like that. So you have like an enormous amount of flags and you pass them to the Java runtime. So I suppose this is basically what they were trying to address with these JSON files, right? Instead of like passing shit ton of flags, you just pass one single JSON. Not XML. Exactly. This is what surprised me. Like, what the fuck, Microsoft? Are you okay? Why this shit is not XML? They hired somebody else in here. They definitely hired some web devs, right? So it's two different teams. So the XML was developed by the enterprise team, by the Java enterprise team, and this shit was developed by, you know, Zoomer JavaScript web devs, right? So you can see different generations of developers piling on top of this tower of abstractions. Anyway, so we have to put this kind of stuff in here, right? So, and after that, well, we need to save this entire shell. If you try to, it runs. So that means if you do that correctly, right? So if you also have a runtime config and stuff like that, the executables produced by mono ilasm are also runnable with the Microsoft runtime, which is kind of good, right? So we target both of the runtimes now. So that's pretty cool. What can I say? That's pretty cool. So, and another interesting thing in here is that, like, there's a little bit of a problem, is that string is its own entity within the runtime of .NET. And this is kind of a problem. Because the way we work with strings in our programming language, right? So let me actually try to like demonstrate you. So let's take a look at the hello world, right? So here's the hello world. If you compile it, run it, so it prints hello world. We can even take a look at how hello world looks like. Now, nothing particularly special. So here we have one single string, right? We have a one single string. So if you take a look at the intermediate representation, right, of the compiled program, so an intermediate representation is basically our bytecode, right? So it's basically our bytecode. So what it does in the main function, it calls external function printf with the parameter data 0. So essentially within our memory model, within the model of our sort of virtual machine and stuff like that, we have so-called data section. Here is the data section. And when you, what we do in the data section, we store strings in there. So the reason why it is a data section is that because I thought maybe we're going to store more stuff in there, right? More immutable stuff and stuff like that, right? But we kind of ended up storing only strings in there. Right, and when you're referring to a particular string, you're actually referring to an offset from the beginning of the data section. So it allows you to actually sometimes refer in the middle of the string and stuff like that. Not like we do that, but you can technically do that. And it's kind of different from the model that I see in here, right? So where string is literally its own kind of entity that you push on top of the stack, and as you can see, when you call this function, it expects this entity to be of the type string. So it even the frames of this argument stack, they have a type attached to them, it seems, right? So I'm not a specialist on .NET or CLI or anything, but it seems like this stack that this virtual machine is operating on, like actually kind of keeps track of the types and everything. Right, that's what it feels like, which is kind of different from what we are trying to do. And what's funny is that this kind of discrepancy between how we handle strings and how other targets handle strings, this is something that I noticed a long time ago, right? So, and I felt like instead of like having this kind of thing, right, we should have a similar model where string is also its own entity, and it's up to the target to store those strings somewhere, maybe in a data section, or maybe directly translate them to whatever the target provides and whatnot. So yeah, if we take a look at the intermediate representation, specifically enumeration arg, which allows you to refer to different kind of arguments, whether it's a local variable, whether it's dereferenced variable, and so on and so forth. And referring to data section is DataOffset. Right, so this is DataOffset, and here is an offset. So what I wanted to do some time ago is to replace DataOffset with something like string const cchar, right? So string const cchar, it's one of the arguments, and then it's going to be the responsibility of the Codegens of the targets to do something with those strings and to store them appropriately and whatnot. Right, but doing that, it's a huge refactoring that I don't want to undertake right now. So we'll have to insert a little bit of a hack, right? We have to insert a little bit of a hack. So I think we're going to go with the data offset, and we're going to be treating data offset as, you know, a reference to a string, even though name kind of implies that data offset may be referring to any kind of data. Just for the sake of simplicity and for the sake of a hack, I'm 50 FPS again. Can it be 60 FPS? Okay, so am I 60? No. Anyway, so for the sake of the hack, let's assume that this offset refers to a unique string, because this is how we use data offsets anyway, right? So every time we use data offsets, it's referring to one unique string anyway. So, but it refers to the beginning of the string. It refers to the beginning of the string, but how do we know the end of that string? How do we know the end of that specific string? Well, one of the things we do is that we null terminate them, because it's a predecessor to C. We're working with the predecessor to C, and all of the strings are null terminated. So in fact, I can even demonstrate you that. So if I have hello world and modify this entire thing, so hello world and foo bar. So let's take a look at this entire thing. So hello world and foo bar. Let's take a look at the intermediate representation. So as you can see, in the data section, we have hello world, and then comes foo bar. So, and in here, at the end of this hello world, we have 0, then here comes foo bar, and then 0 again. So we can basically use this offset of the intermediate representation as the ID of a unique string, and then we can look up within the data array in here and find that string, and we know the end of the string because it is null terminated. So this is how we can sort of like hack all of that stuff around. This is how we can try to do that. Right, and that hack already allows us, I think, to make that hello world compilable. Right, and that's our goal for today's stream anyway. Right, let's go ahead and do that. So the problem with this assembly is that it generates like fuck ton of crap. Like a fuck ton of craps, which is not even needed, by the way. You don't fucking need it, right? So you can like literally remove that shit, and you can try to compile this entire thing. Where ilasm, there we go. It's still compilable. So as far as I know, you can even remove this stuff, and it's still going to be compilable. Right? I don't know why it generates all of that stuff, but it kind of works. It actually generates also a warning in here, which is kind of it generates it all the time. All right, so you can't get rid of this thing, right? So if you try to remove this entire stuff, it will tell you. No, it just tells the warning. Reference to undeclared external assembly MS core lib adding. Right. If I just do that, it generates less warnings in here. Okay, so you definitely don't need this stuff. Right, and here we have some class. It doesn't have to be private, it doesn't have to be ANSI, abstract, sealed. It can be just class, if I remember correctly. You can just make it class. Yeah, so you can just make it class, and we're going to be extending the system object. And in fact, like, it has a weird name, but let's actually keep this name. So we have some sort of a constructor in here. I'm not really sure if this constructor is needed, right? So I can remove that as well. So we have this like weird method. It doesn't have to be private. It doesn't have to be any of those things. As far as I know, the only thing it has to be static, right? So otherwise you won't, otherwise you won't be able to do that. So max stack is also not needed. Entry point is needed. If you get rid of the entry point, it doesn't have entry point, so you kind of need all of that stuff, right? So obviously you don't need any of these comments. Right, so all of that is just generated by assembly. That seems to be working. And it also generates like a label for each individual instruction, probably for the sake of telling you the address, right? So, or whatever. You also don't need any of that stuff in here. Right, so the ilasm is actually extremely simple. It is actually extremely simple. You don't need any of that crap. Right, so you don't need any of that crap. So it's actually pretty simple. Look at that. Look at that. I can even call this entire thing maybe several times, right? So, and if I just do mono main exe, there we go. So it's actually prints that a couple of times. That's pretty cool. That's pretty cool. So now we have like a minimal thing that is very easy to generate. It is insanely easy to generate. Let's go ahead and do that. So within our compiler, right? So we need to add a new target. So where is the list of targets in here? So here's the list of targets. We have x86-64 for all of the three major operating systems, Windows, Linux, and Mac OS. We have ARM for only Linux and Darwin, and we have UXN and MOS6502. So we need to introduce another one. So obviously this one is probably going to be called ilasm. And for now, we're targeting mono. Right, so I'm gonna put mono in here just in case. But later, I kind of want to get rid of the mono and just like imply that we can work with any runtime. We're just generating stuff for ilasm, and as far as I know, there is ilasm from Microsoft, the official one from Microsoft, right? So, but for now, just for the sake of simplicity, right? So I'm gonna say what we are only targeting mono, and then we're gonna expand it, right? So that's going to be the idea. So as we edit this target in here, so the compilation is going to break in all sorts of places where we match upon the target, right? So that means we're not going to be handling one of the branch that we just edit. So let's actually go and try to compile this entire thing and go to all the places where all of that is failing. Okay, so we need some sort of the official name for this target. So I think the name is going to be something like probably ilasm-mono. So this is the name that is going to be used in logging to display the human readable name for the target, and also when you specify -t, right? So when you compile something, you want to say, okay, I want to compile to that specific target. This is the name that is going to be used in here. That is the name that is going to be used in here. So it's a very important method in here which gives an identifier to the target. So, and that name is going to be used throughout the code base. Right, so let's actually now go to other places, and we are still in B. Okay, so this is the match after we finished compiling, right? So after we finish compiling, we acquired intermediate representation of the language, and we need to pass it to the Codegen. So this is exactly like where it is done. So ilasm-mono, and in here we have to pass it to the Codegen. Pass to the Codegen. So for now I'm going to put to do in here, so let it crash. And now where is it failing? So it's actually target. I'm supposed to prefix it because it's Rust, obviously. So now it's probably failing somewhere in btest, right? So it's a testing tool. Okay, so in here we have to specify what extension for the final program is expected when we're testing this entire thing. Well, since it's exe, it probably only makes sense to say that it's going to be exe. Right, so it's going to be ilasm-mono, but it may kind of collide. With this exe. So what I'm thinking is that maybe what I'm going to do, yeah, it probably would be nice to prefix it with the target. Nah, I'm going to do that later. So, the thing is, like, it may only collide if we test in parallel, right? If we test in parallel, so we have to. I'm going to put it to do. So target ilasm may collide with this particular target if we introduce parallel runner, right? So I just don't want to think about it too much right now, right? But this is something that needs to be addressed at some point. All right, what's going to be the next thing? What's going to be the next thing? And this is the runner, right? So after we compile the program in a testing tool, we have to run it somehow. Right now, we don't really have any runners in here, so I'm going to just put it to do. Right, so I'm going to just say to do, okay, run. Okay. Okay, and that's it. So this is how you add a new target, like a new empty target to the compiler. So now if I try to do list me the targets, there you go, here is the target. So here's the target. So I can now even try to maybe compile something with that specific target. So we're already trying to compile things. So hello world, right? So we want to build hello world, and it crashes, right? So because pass to the Codegen. So what's interesting is that like it already successfully compiled the program, but now it needs to generate shit, but we don't have a generator for that. And this is something that we have to implement. All right, let's go ahead and do that. So we have a special folder in here where we keep all of the code gens, right, for ARM, x86-64, for MOS6502, NuxN, whatever. So we need to introduce ilasm-mono.rs, ilasm. So, and this is going to be a module within this bigger module, right? So we basically have a tree like Codegen, and within the Codegen we have all of these things in here. So let's actually introduce something like this, ilasm-mono. This is the new Codegen, and usually if you take a look at the Codegens, they provide a single entry right into them, which is called generate program. It accepts the entirety of the compiler. I kind of want to actually separate the state of the compiled program from the state of the compiler. We already discussed how to do that on one of the previous sessions. Like I didn't come around to actually properly do that yet, but I'm going to do that at some point. Right, so this is the entry that we have to supply right now, right? And it also accepts the operating system. We don't really distinguish operating system right now, so we don't really care. Let's put it to do in here, right? And this is the thing that we have to call in here. Right, so let's go ahead and do that. So this is going to be Codegen ilasm-mono, and let's just run generate program in here. Let's just generate the program. So it's going to generate the program into this string buffer that we'll have to then save to the file system and call ilasm on that specific thing. Right, so here's the compiler. And this entire thing may not fail, right? I don't think it may fail, so we're going to just put this thing in here. So after that, we have to like save all of that stuff somewhere. So let me see how we're going to be doing all of that. So let me find something like Windows. First, we have to figure out the base path, right? We have to figure out the base path where exactly we're going to be saving all of that stuff. Here's the base path, and here's the effective output path. I'm not really sure if we need effective output path. It's a final exe, but we do need the output asm path, Right, so yeah, so we take a garbage base. Garbage base is a place where we put all of the garbage in here. So for those who doesn't know, essentially when you compile something, we create .build folder where we put all of the garbage in. So that's what garbage path is, right? So it's kind of important to know where the garbage path is. Like you have to compute it, and this is where we're going to be saving all of that stuff. All right, so I suppose the extension for ilasm is IL. Right, so that's the extension, and then we're writing the content of this entire thing, and then we'll log that we generated this entire thing successfully. I think that's enough for now. So now let me try to maybe recompile and run the whole thing. Recompile and run. It doesn't compile because it doesn't know what is a string builder. It comes from knob as far as I know. So this is a crate knob, that's just basically everything, right? So we probably also need the compiler from the crate. That's the thing we need in here. So a bunch of warnings or whatever. Oh, there was an error in here. I think I missed it. So, and yeah, it has to be mutable. It has to have to pass it by a mutable thing. Okay, look at that. So what do we have in here? Compiling files that directory already exists, and it didn't log that it created the file, right? So probably I have to do that explicitly. This is probably something that I have to do explicitly, whereas the Windows, when we... Yeah, so it didn't really say that it generated this thing, which is kind of weird. Is that because I didn't compile generated? Yeah, it didn't say that. Look at that. Okay, let's actually not do any to-dos in here, right? So let's just let it be empty. Okay, so, and now it said that it generated this thing in our garbage folder. So as far as I know right now, it is completely empty, right? So at least now it outputs an empty file, which is already good, right? So output an empty file is at least something. Okay, so let's actually go to the trash and see what exactly we have to put in here, right? So this is the 2 lines that we have to generate first. Let's go ahead and just literally generate them. So this is going to be sb append. So into the output, this is a C string. Let's put new line in here. Okay, so then we have to generate a class, right? So sb, so I forgot the semicolon, spends 3 hours debugging. Excuse me, I forgot additional things in here. Jesus Christ, bruvskis, what the fuck is going on? Okay, so let's actually copy paste this stuff in here. So this is the new line, and then at the end of this entire thing, let's close the class. Let's close this class, and yeah, I can already probably test this entire thing. Let me try to run this entire stuff. It doesn't compile because what do you want? It wants a freaking C char. So I probably have to use core FFI and something like that. Okay, so let's take a look at what it generated. Cool. So this is what we generated from Hello World B. Right, this is what we managed to generate. Isn't it poggers, my dear friend? I think it's pretty fucking poggers. So it's nothing, honestly. It's fucking nothing, but we managed to generate something. I wonder if it's already compilable as it is. Let's actually find out. So what we need to do now, we just need to call the ilasm. So let's do cmd append. This is how you use cmd append. And what we're gonna put in there, I suppose, is ilasm, and we have to put output asm path in here, but we also have to redirect the output of ilasm into the garbage folder. So this is what we have to do. So where is the garbage folder? Ilasm, not really garbage folder, but ilasm. So you have to do output file name. That's kind of bizarre, right? So that means I have to concatenate the strings and shit like that. All right, so let's concatenate the strings. So here is going to be the file path, and the output is going to be effective output path. So I have to put this thing somewhere here. So tmp as printf, like so, effective output path. All right, let's try to compile this entire thing and see if it's going to produce anything reasonable. Okay, so did it call anything? Yeah, so after that I have to actually run the whole thing. Might as well also copy paste this entire thing and just say that running this entire thing is not implemented yet, even though it's actually kind of easy. You just pass the executable to the mono and it just works supposedly. So anyways, let's fucking go. Okay, so it tried to compile and it says no entry point. It just says no entry point. Let's maybe introduce some sort of an entry point in here. So ilasm-mono. So the entry point is going to be something like this. So the idea is going to be, okay, we're going to always generate an entry point and we're just going to call a main method. I guess that's going to be the idea, right? Just like similar to how we do in C and stuff like that. Right. So can you generate a DLL if there's no entry point? This is not something that our compiler does anyway. Right. So we don't really support creating libraries yet as of right now. So I don't think it makes any sense for us to do that. All right. So let's put this stuff in here. So maybe might as well just indent things. So after that, we could probably put a return in here. All right. It didn't compile because I forgot this thing. I probably also have to close this one. Okay. Still says no entry point because I have to explicitly mark the entry point. If I understand, yeah, so I have to put entry point in here. Entry point. All right. Let's fucking go. And it compiled successfully. Right. We can even, again, as I already said, we can try to run this entire thing already. We can just pass the name of the executable to mono. And since the target is called ilasm-mono, it effectively should probably make sense. Right. So we just take the effective output path. Right. And yeah, so the runner and linker for this platform is basically already implemented, right? So because that's what you do, right? So you just grab the assembly and just do all these manipulations and you've got the .NET target or mono target or whatever. So did it even, yeah, it didn't run it because I didn't provide the run flag. If I try to run it, did it try to run it afterwards? I didn't see whether it ran it or not. That's bizarre. I see that it had compiled it, but I don't see if it ran it or not. So did I make some fucky-wacky, motherfucky? Yeah, I did, of course. I forgot to CMD run again. It happened second time, actually, by the way. Speaking of, yeah, okay. So try to run this entire thing, but it didn't do shit. Didn't do shit. Yeah, so now we have to make it do some shit. Let's actually see. So let's go into ilasm and maybe, you know, iterate some functions, right? Let's actually go ahead and iterate all of the functions we have in the compiler. So struct compiler. So here are the functions. Let's go ahead and iterate them. So this is going to be C, like this, funcs. This is funcs, and I think it's count, right? So let funcs items add I. Right, so here's the function. And just to see how many functions we have in there, let's just print each individual function in here. Like so, it probably has to be sbappend output. So this is going to be a comment, maybe even indent this entire thing. So this is going to be func with a specific name, and the name comes from here. All right, so now if I try to compile this entire thing, it kind of failed. So yeah, it has to be something like that. All right. So if I take a look at the ilasm, the only function we have in here is main, right? That's the only function we have in here. We can try to maybe add more functions, for example, foo and bar. So by the way, in B, this is an empty function. This is not a forward declaration of the function. This is an empty function. Right, so if I try to compile this entire thing, it still compiles. And if I revert this entire stuff, there we go. Here are all of the functions that we have in intermediate presentation. Now we have to basically generate their body as methods or something, which should be pretty straightforward, I think. Which should be pretty straightforward. So now I'm going to go to ilasm-mono. And for each of these things, I suppose we're going to use the same idea, is that this is going to be a static void method, right? But the name is going to be the name from the function, right? So this is a function name. In terms of the arguments, I think we're not going to accept anything. So we have to return an integer in here. I don't remember how to do the integer. Is it int or something? And this is going to be the body, right? So which we also have to generate. Though having a return in here, I think it's just generally a good idea. Okay. So let's actually see. What does it say? Irrecoverable syntax error. Okay, that's pretty scary statement, not gonna lie. What do we have? So it's 4. Yep. I'm not quite sure what the fuck you want from me because, yeah, that seems all right. Is that because of the int? Is that because of the int? Oh, that was weird. Why did I have? Yeah. I have some weird naming in here. So what if I put void in here? What if I put void? Yeah, so int is not something that you can have in here. Okay, so let me take a look at the trash. Let me take a look at the trash. And so what if I have something like a int x69? Maybe a function static int foo, right, return 16. I think I won't be able to do it like that in C#. I think I won't be able to do it like that. So it's going to be mona csc main cs and expected semicolon. So that's understandable. Oh, apparently I can't do that. The local, oh, it's a local function declared but never used. Might as well start using it. So it's probably within the another static method this entire file is wrapped in. So that's probably what's going on here, but I'm not really sure. The only thing I need to see is how you do integers, because I don't quite remember. So monodis main xz, just show me. Int 32, so it's probably int 32 in here. So is that a 32-bit platform? I remember there was like int 64 or whatever. Is there int 64? Can I say int 64? I kind of vaguely remember there was int 64. So I need to do monodis and then mono, not really monodis, but mono csc main cs and monodis main xz. All right, so int could not be C# 64-bit integers. Jesus Christ. Well, how do you call them? How do you fucking call them? I don't remember. I don't even know. Not really remember, but long. Okay, sure. All right. It's literally int 64. Okay, so it does support all of that stuff, which is nice. Okay, so let's go ilasm-mono. I wanna go to src Codegen ilasm-mono. So I just want to return int 64. Int 64. Big int. Yeah, maybe that's what it is. Big int. And now let's do main and let's just run this entire thing. Okay, that compiled. That compiled. It even run, but well, I mean it didn't work, right? So because there is nothing in an entry point, right? So there's nothing in an entry point. One of the things we want to do in here, we want to call an external function, right? So how do you even call these external functions? Not really external function, but I mean just another function within the same class. So you use call. Okay, that's understandable. Right, that's how we do that. But here we're calling a function from like a different module, like a different library, mscore lib. Since we're calling a function from the same thing, probably we don't have to do that. So we're also calling a specific class. The name of this class is kind of weird. It's called like program. Can we have a normal name for a program in here as well? Or do we have to just like directly do this kind of thing? So I can try to do that actually. So since it's a static method, doing something like that should be all right. And here comes the name of the method, which is main, right? So we kind of expect main. I wonder if this is okay, or do I have to put that stuff in here? Kind of difficult to tell, but anyway, let's go ahead and try to do that. So, and yeah, method not found. But it's a static method. So maybe what I have to do, I have to put static in here. Do I have to put static in here? So irrecoverable syntax error. Okay. That's very interesting. So maybe I just have to, how do you call the other static method? Let's go ahead and try to do that. Let's go ahead and try to do that. So we have a trash, right? So, and that means we can experiment with all of the trash. So I kind of want to go back to like a class main, right? And here I want to have like a static void main, which is a string args, and this is what I want to basically do in here, right? So this is that a valid C#? I don't know, right? So I know nothing about C#. Okay, let's actually see. So name, yep. So same as their enclosing type. What the fuck are you saying? So it's a valid Java almost. Yeah. Okay. So C#, hello world. Class needs to be something else. I don't know. So it's probably gonna give me the hello world that is reduced version, but I need a full version. All right. So this one doesn't even work. Yeah. So reduced version. I don't care about reduced version. Show me the full version. Show me the full version. Like, bro. Microsoft is thinking that I'm a moron yet again. Classic. Anyways, just give me the full one. Oh, for fuck's sake, bro. So is there something like a Rosetta? Rosetta code C#. Where's the code, bro? Oh, like, okay, so this is stupid. This is fucking stupid. This is insanity. Like, why can't I find a very basic thing? I don't want to ask ChatGPT about such a stupid basic thing. Like, just give me fucking hello world. Yes! Fucking finally! Right, okay, so it's a static public. Static public. Okay. Is that it? Okay, so I'm gonna just like remove all of these things. I'm not sure what the fuck you want from me, but so it probably has to be program. Foo does not exist. Okay, can anybody tell me how the fuck this is a good error message? Member names cannot be the same. The same as an enclosing. Jesus Christ! For some reason I couldn't comprehend. Enclosing type something. So, anyways, kind of weird word enclosing. It kind of confused me. But anyways, whatever. So this is what I wanted. How do I call an external thing now? Right. So to call an external is going to be program foo, right? Like, why didn't they say that? Like, the name cannot be the same as the class name. The name of the method, enclosing something. Like, are you okay? Why are you using such a weird language? Okay, alias program not found. If I just call this thing. All right. So what I want. How the fuck do you call it? Instance void. Oh, it's a constructor. Okay. So, but where is the entry point? Call class. All right, so this is exactly how you do that. This is exactly how we do that. And the class in here has actually a normal name. Let's actually call it program. I think it's going to be an interesting idea. So yeah, because it's a really weird name in here, right? So this is going to be called program, right? So this is program. Let's call this name, and this one is going to be program. All right, so now I'm going to just try to recompile this entire thing, and irrecoverable at 15. All right, let's take a look at this entire thing. So what's going to be 15? How is that? Like, because it is int64, right? Because it is int64. What was the? I already forgot. What was the call? Yeah. So we need to save it somewhere. Yeah, let's actually put it in here. Let's actually put it in here. And yep. Ilasm. Where is that? It's a little bit hot in here. And maybe I need to make a small break at some point. So this is what I wanted, right? This is what I wanted. Okay. So let's try to recompile this entire thing. All right, so it seems to be a runtime exception. Invalid ill code. I have a feeling that maybe it is because it's supposed to return something. So this entire thing returns some stuff. Or maybe this is because this thing is supposed to return something. Let me see. How do I even return anything from this entire stuff? So I remember there was like a LDC. Yeah, LDC type. So 64. So we have to do LDC I8, I think. LDC I8, and it just returns 0. All right. So if I try to run the whole thing, so it is something with the return. Is that because, what if I just return, is there drop? Can I drop afterwards? Drop. LDC. Does anybody see any sort of like a drop instruction? So does anybody see any drop instruction? Maybe it was nop. Nop, no operation. Pop. They call it pop, not drop. All right, so let's do pop. Because this thing definitely returns 64, right? So, and we're not interested. I feel like red maybe fails because of that, but I'm not 100% sure. Not 100% sure. Maybe that's the... Okay, it was failing because of that. Yeah, it was failing because of that. Cool. All right, so, yeah. We have an entry point which calls the function and everything. So now we need to generate some shit, right? So we need to generate some shit. So to generate some shit, we need to go through each individual operation of the body of the function, right? Of the body of the function. So let's actually maybe create like separate stuff. Unsave fn, generate funcs, right? And this is where we're going to be doing all of that stuff. Generate funcs. I'm going to put it in here, and for each individual function, we're going to be generate function. Right, and here is the function is going to be just that. And this is where we're going to be doing all of that stuff. Generate function, func. So this is going to be basically prologue and epilogue of the function. And in here, we're going to start iterating all of the ops in the body, So where is the struct func, right? So here is the body. So this is operation with location and so on and so forth. We even know the location within the source code where each individual operation is located, which is kind of cool. So now func body, what is it called? Count, right? So it is count. And for each individual thing, so here is the OP func body items. We're going to do offset, and we're going to just dereference it and get this entire thing. And let's match each individual opcode. So where are my opcodes? Of course, we have a bogus amogus opcode. Bogus amogus opcode is something that produced during the compilation, and we should never encounter it in a Codegen. If we do encounter it in a Codegen, that's an compiler bug. That's a straight up compiler bug. Because of that, we have to say that this particular thing is unreachable. Bogus amogus. So it's usually generated when the compilation already failed, but the compiler continues compiling things because it tried to gather as many diagnostic errors as possible. So that's why this thing exists. So the compiler should fail compilation at the first error, but it wants to report as much as possible. So, and if the Codegen encounters this particular OP, that means the compiler, for whatever freaking reason, passed a broken code to the Codegen. So it should never happen in here, right? So it's a bug, straight up bug. All right, so let me kind of indent this entire thing. Can I query replace space with nothing in here like that? Right, so, and query replace this with that. I unindented this entire stuff. I wonder if I can just do something like that, and a boom, like this. So, and in here we can probably put a to-do of some sort. I'm gonna grab this entire scheiße, and that should be enough. And let me align all of that stuff by that. So now, when we try to compile some operand, it's going to fail in a coding place, hopefully, right? So that's pretty cool. So what we have to do now is just like we have to try to compile one of the source codes and see on which operation it is failing and just implement that operation. And maybe eventually we'll be able to compile any program to .NET. We'll see. So it's kind of similar to implementing virtual machines. Very, very similar. We have some compilation errors. So func is this thing. So let's actually put the stuff in here. So then output. Oh yeah, it does need output. So it's going to be mutable string builder. So what else do we have in here? OP. Okay, so this is another thing. So we have to import all of these things in here. What's the other thing? So generate functions, it's the compiler. So in here, I suppose we have to accept the slice of the functions because it's a slice now. This is going to be len. And in here, as we dereference this entire thing, it has to be something like that. We're just iterating le slice. What's the next thing? Funcs. Yeah, it's a plural one, of course. It is in fact a plural. Generate func also wants the output. Let's grab the output like this. Here is that. And what's the next thing? Generate funcs. So generate funcs wants the funcs which are available in here, but they are a dynamic array. So we have to convert it into the slice and then provide the output. Is bcompile optimizing? No, not yet. But some people are working on it. Some people are working on it. Maybe at some point it's going to be optimizing. So, okay, we tried to compile hello world, and it failed in here. By the way, why I'm not using missing? It's going to be way more poggers, my friend. It's going to be way more poggers. So missing, and in here we have to provide the location where exactly it's missing. So op lock, and hopefully it is going to work. So I think it won't find missing. I think the way to get it is from the crate, the root crate thing. Missing, no, yeah. Holy shit. Oh yeah. So this is because all of these things have to be string literal. So I did a little bit of a fucky-wucky and potentially an oopsie-doopsie. So no, it is not the case. What the fuck is going on, brovskis? Cannot find function fprintf. Oh, this is because I also have to take crust and import everything libc, right? So because without libc you can't report shit, brovski. Okay, so and obviously I probably forgot to put a new line somewhere here. So let me grab the missing and put new lines in all of these places. Just fucking let me do that. Emacs, just shut the fuck up. Shut the fuck up. Cool. So to do OP Funcall, couldn't do Funcall, go implement it in here. Right, so if it's trying to compile something that doesn't have implementation, it tells you, okay, so this is where like we don't have this kind of thing, and this is where you have to implement this kind of shit. So, and for now, we have to only implement like this Funcall thingy. This is the only thing we have to implement. Okay, so how are we going to be doing all of that? How are we going to be doing all of that? So, by the way, on top of that, we have like in functions themselves, we have a notion of like automatic variables that have to be allocated on the stack. So we have to do kind of a similar thing. As far as I know, as far as the node chat, .NET has local variables, so-called local variables. I don't remember the syntax. I do not remember the syntax, but I remember that it did in fact have local variables. So essentially, each individual automatic variable of B, right? So an automatic variable of B is in fact just a local variable, just a local variable. So there's kind of a funny history behind the name of automatic variable. Is that back in the days when B was invented, automatically allocating variable on a stack and automatically deallocating a variable from the stack was a new technology. It was fucking revolutionary, because before that, people literally had to do that manually. In assembly, if you program in assembly in 2025, you still have to do that manually, right? So you allocate some stuff on the stack and you deallocate it. This idea that you just say, okay, so I have a bunch of variables here in the body of the function, and it automatically does it for you. This was a fucking revolution. People use global variables, right, instead. Like holy, this is genius. And garbage collector was not even a thing back then. It was just like, no, it's like, holy fucking shit. And that's why it has a special keyword to signify, look, we're using cutting edge technology. In 1969, cutting edge technology, automatic variable allocation. So, and that's why it's called like that. These days, we just call them local variables, right? It's kind of funny that something back in the days was considered like a cutting edge. Today is just like, yeah, that's how languages work. Like, what do you say? It wasn't like that. That's the programming language. That's how the fucking they work. So yeah, in C#, they're called local variables, and you actually allocate them like one by one. Didn't GC already exist? I'm actually not sure if it did exist. So when was first GC actually invented garbage collector? I have a feeling that it didn't exist back then, but who fucking knows? Wikipedia, motherfucker. Wikipedia, give me Wikipedia, blядь. Сука. Sorry. So is there any history on overview, disadvantages? Disadvantages, history. No, it doesn't have any history. It just always existed, guys. It's garbage collector just always existed. The good old days when Knuth was arguing for making a language that allowed recursive function calls, and people were saying it was impossible. Yeah, so it's kind of interesting. Imagine like going back to those days with all the knowledge of computing and language design you have today, and arguing with Knuth. Imagine. Honestly, when you think about it, maybe we did in fact have some progress in software technology since then, right? So imagine, yeah. So anyways, brothers, anyways. So how do you even allocate these shits? Let me see. So where is the trash? I want my trash, chat. I want my trash. So fuck that. Let's do var x69. So I came up with a banger name for a variable, var crimes. It's a var crimes. It's a fucking var crimes. Anyway, I'm sorry. I'm so fucking sorry. This is so fucking dumb. Anyway, so how do you do var crimes? Got you, motherfucker, got you. So this is how we do that. Locals, init. Lots of var crimes, yes. So what if I have like a 34, and let's actually call them A and B. Okay, so locals, look at that. So this is a cool idea. We already referred to autovars by an index. We can literally do the same thing as the compiler, as the monocompiler. So we can just like allocate n of them, and each of them has the index. So, and then we can, as we generate the code, we can refer to them by the index. I kind of like this idea. So let's go ahead and freaking do that. All right. So if I remember correctly, in B, so struct func, so there is a, yeah, you also have to take into account the parameters, right? So you have to take into account the parameters. And the thing we're interested in here is auto vars count. Let's go ahead and do that stuff. So I'm going to iterate func auto vars count. This is an auto vars count. And I'm going to put this thing here as le tabs. Disgusting. Okay, 1, 2, 3, 4. Boom. I'm going to put this thing as a reference. I wonder if we can just like, you know, straighten this all stuff up like so. So it's a little bit easier to generate. And obviously, I personally would like to actually have 64. We're going to consider this to be a 64-bit platform. Okay, so this is basically what we need to generate. In fact, we index the auto vars starting from 1. Because of that, I feel like it would be actually easier to number them like this. Right, I think it would be easier to number them like this. So, oh man, is this Rust? Yes, we're generating .NET assembly from Rust on Linux. This is the kind of shit we do on this channel, okay? And ironically, by the way, I'm not trying to do a meme or anything. I'm just doing that as a recreational activity. I'm exploring. This is research, okay? This is not a meme. This is a fucking research. But honestly, researchers these days are also memes, right? Remember like Cox Zucker machine, right? So something like Cox Zucker machine. Yeah, so that's the kind of science people are doing, were doing in 1979, still probably doing. And they don't even hide the fact that that was the intent of the paper that they wrote. They don't even hide that. They've been like proud of it. So yeah. So for anyone who's interested, there we go. Cox Zucker machine. So I'm gonna put that in la description. Anyways, so yeah, let's iterate all of that stuff. So we need to do append. Any epic Cox Zuckers in the chat? So we probably have to actually prepend this entire thing in here, like so. This is going to be locals init. I made locals init, and let's close this entire shit at the end in here. The hour is over. Tea break. Nah. I'm gonna pour some water though. Just a sec. Just a sec. Few secs. I'm back. With my tea, not tea, but water. Mr. Zodian in the flow, unstoppable. Yeah. I don't need a break right now. It would be kind of cool to maintain this state on each individual stream all the time. But I think to do that, I guess I have to be chain smoking. Too bad I quit smoking a long time ago. Anyway, it's just like a Tokyo Spliff can maintain this kind of state for like 10 hours straight, but at the same time he's like a chain smoking. I can't do that anymore, I'm sorry. So, what do we need in here? We need to do int64, and it's going to be something like that. So it's going to be ZU. Have you considered Adderall? Nah, thank you. Honestly, I'm trying to reduce the amount of dependencies, third-party dependencies in my life. So thank you very much. Anyways, so what I want to do in here is that if I is greater than 0, then also sb append output. So honestly, caffeine is more than enough for me as of right now. is more than enough. Third-party dependency, yeah, I know. Haha, funny yoke. Funny yoke. Alright. So let's try to compile this scheiße broskis. Fuck. Let's go. Funcall. It's kind of annoying in the sense that we are accumulating the assembly before actually outputting it, and if we encounter an error, it's never outputted. So it's kind of a bummer. Okay, so let's actually try to maybe do the following thing. I'm gonna do sb append. So output, and the thing I'm gonna append is comment saying that this thing is not implemented yet. Ooh, can we output the intermediate representation dump? Can we just dump it there so we can actually clearly see what is called and stuff like that? Okay, generated some Shaisung, right? But yeah, it's kind of useless. And by the way, I forgot new line and indentation and stuff like that. All of that is shit. Fuck that. Everything is shit. Everything is fucking shit. I'm sorry. Much better. Thank you so much. Okay, so maybe I would like to maybe indent it slightly more, honestly. Just a little bit, a tiny bit more. How about that? How about just like a tiny bit? It doesn't really like, even though I don't understand that nobody's gonna read that code, right? So because it's just like automatically generated, but still, when I'm inspecting it, I want to be able to actually see what the fuck is going on. By the way, we generated all of that shit from the B program, right? So what we're doing right now, we're compiling this program to .NET executable on Linux. I don't know why my camera is 15 FPS. I'm sorry. I'm a poor Russian. I don't have any money to buy a proper equipment. So I'm in the middle of Siberia. But anyways, right. So this is the program in B. So you have hello world with 2 calls to hello world and 2 empty functions, and this is literally what we generated in here. The camera looks fine. I think it's a little bit FPS is kind of like fucky-wackish, but anyway. Right, so this is what we have in here. Honestly, like if you don't have local variables, maybe it doesn't make any sense to actually generate this entire thing. Gulag coding said Gulang. Yeah, so somebody should create a language called Gulang. Or something like that. This is a Gulang. Программировай, сука. Anyway. Gulang. Программировай, сука. Давай. Опа. Thank you so much for all the subs. I really appreciate that. So what I want you to do, I want you to basically put some sort of a condizione saying that if you don't have any auto vars, don't fucking generate anything. I think that's fair. I think that's a fair statement. So if this thing is greater than 0, just do not generate that stuff. Just do not generate that stuff. Let's fucking go. Okay, as you can see, we don't have any local variables in here, so we don't generate anything. We have some local variables in here. We generated 2 local variables. So this is shit, by the way. It doesn't tell you anything, right? So what I would like to generate instead is something akin to that, right? If something is not implemented, just generate a comment with this specific line. I think that will be kind of poggers. I feel like it will be kind of poggers. And what's interesting is that I think we can do that in a Codegen. Thank you, so many subs. 63 more to go. 63? But are you subbed for 63 months? Let me verify that. 6 months, not 63. You're lying to me. Mods, ban, permaban. No, don't ban, I'm joking. So here's where we dump in all of these shits. So you can only dump an entire function. 63. Okay, more to go. I see. No, bots unban this person. Yeah, I want to factor out this entire thing to something like dump OP, so I can then reuse it for generation and stuff like that. So dump OP. I'm gonna just grab this entire thing, put it in here, and this one is a dump OP. Might as well even inline the whole thing. It probably needs the output in here. So provide financial compensation for suffering experience. Well, I mean, I don't get anything from that, but I mean, whatever. Lifetime ban protection granted. Yeah, nobody's protected. Okay, guys, so let's try to compile this, and I think it doesn't work. Boosie! Okay. OP, so yeah, here we have to accept, I suppose, OP with location and the string buffer. String, not really string buffer, but string Boosie! B-use. B-movie. What the fuck is going on? So what I want to do now, chat, look, I want to remove these shits. Then I want to call dump OP, I provide OP, and I provide output. So as far as I know, dump OP by itself puts a new line. Yeah, it puts a new line at the end. I don't have to worry about that. This is epic, I think. So, and I probably have to do the following thing. So it's a create Codegen IR. So that's what I'm doing. Okay, let's fucking go. So, and now I'm gonna be just generating the code, and let's take a look at ilasm. Look at that. So basically it just prints you the intermediate representation of the thing you have not implemented yet, so which is rather convenient. I think it's rather convenient because it doesn't fail a compilation per se, right? But it just like tells you like this is where you have to do that. I think it's a bit more convenient. We might as well even put it to do in here. Who said we can't do that? Right, so okay, so can I do auto revert mode? Auto revert mode. Yeah, look at that. So in a auto revert mode, I can change things like fix me, then go to the compilation, and it automatically changes to fix me. Then I can go back, then I can recompile this thing one more time, and it's automatically to do. That's kind of convenient. Especially for generated code. I don't really plan to modify this file, but I want to be able to see the changes right away as I change them. So this is auto revert mode of Emacs. Can your Vim do that? Oh. Probably can. Is there something like auto revert mode in Emacs? I don't fucking know. I don't even remember. So maybe I'm kind of curious. Vim auto revert mode. Revert the default completion or auto refresh, maybe that's what they call it in Vim world. Reload the current file automatically. Yeah. Well, I think I saw something. Auto read. Auto read. So when a file has been detected to have been changed outside of Vim and it has not been changed inside of Vim, automatically read. This is such a funny wording. I don't know why, but I kind of find this sentence to be worded funny. When a file has been detected to have been changed outside of Vim and it has not been changed inside of Vim, automatically read it again. It's clear, don't get me wrong, it's clear, but it's kind of cool. I really like it. Right, so it does have that mode. Okay, that's pretty cool. Nope, get 30 plugins instead. I feel like honestly, Vim comes with a lot of plugins to the point that do you really need to install that much? Unless you want to turn your Vim into IDE, but at that point, like, just use Visual Studio Code if you need IDE. Like, what's the point? I don't quite understand. And honestly, I kind of stopped understanding the desire of Emacs and Vim users to turn their text editor into IDE. Just use fucking IDE if you need IDE. So, I have like a nerd tree and that's it. Yeah, so I think that's a good plugin, honestly. I remember somebody was trying to adapt nerd tree to Emacs, but it never kind of took off within the Emacs community because they have dred. Dred by itself is kind of a slightly different paradigm, and it kind of fills the niche of nerd tree on Emacs. Right, so and that's why nerd tree kind of never worked on Emacs because dred filled that niche. I use oil and Vim. It's similar to Emacs. I don't know what it is. But anyways, okay. So we need to call a function. I just realized. When you call in a function, you actually put arguments on top of the stack. That's what you're doing. So you put in the arguments on top of the stack. So if you have a method in here, let's actually say static void foo, and I have int 64a, int 64b. What I do in here, how do I load parameters? I don't quite remember. So if I want to call this entire function, I do ldc i8 34 35, and then I call void class program sum, right, in 64. I have to provide the entirety of the signature because it kind of polymorphs on that, or like it dispatches at compile time, right? So it does that. I don't remember how to load a parameter. So there is oh yeah, load argument onto the stack. The ld arg instruction pushes onto the evaluation stack the num's incoming argument, where arguments are numbered from 0 onwards. Okay, so that means I can do ld arg 0, 1, right? I don't have to provide anything particularly special. And then I can do sum or add, and in here I'm supposed to return in 64 something like that. So I sum it up, and then I have to probably call this entire thing, which is in 64. Right, so if you call in a function, right, you push its argument onto the stack. Right, you push these arguments onto the stack. So that means in our case, we have to take arguments of the function and sort of recursively evaluate them, making them pushed onto the stack. That's probably roughly what we have to do in here, which is kind of cool. So let me find the definition of the func. Here are no Funcall. Yeah, boy. So we have a result, and this is an index of an autovar into which we're saving the result. Function is an argument that we have to call, and here are the arguments that we have to put on the stack. So essentially what we're going to be doing in here, we're going to be doing kind of similar, I think, to what we do in other Codegens. Here's the x86-64, here's the Funcall. And what we do in here, we iterate through the arguments, and we'll load each individual argument into the register according to ABI convention. What's the order of pushing args? It may be reversed depending on... That's a good question. We're going to figure out the hard way. We're going to just like implement it, whatever. And if our program fails, we will fix it. We just add .rev. So don't worry about it. I try not to think about it too early. Okay, so let's iterate this entire shit. And this is going to be args. And this is count, right? So, and as you can see, we have a special functions in x86-64 that load an argument into the register. But what we can do instead in .NET, we can just load arg, right? Which is going to load it onto the stack. That's what it's going to do. Oh, by the way, for those who didn't know, we have a grok in the chat. So if you have any questions, right, you can always ask grok, is this true? Right, and it will answer to you, right? So for example, this is not true. You see, it answered no. So just for anyone who's interested, we have grok in the chat. It's not as Nazi as the one on Twitter, but it's still, it can answer things. They sued, somebody suing grok? How can you sue AI? You should sue a company that made it. Anyways, let's fucking go. Now, what I wanted to do, I wanted to create load arg function. I want to create load arg function. So, so this is arg, and we also have to accept this thing. I have to accept this thing. So let's match each individual argument. Let's match each individual argument. I wonder how, by the way, the chat on YouTube is going to look like overlay if I put chat in here. I just realized that it's probably not a particularly good idea. I'm sorry, YouTube people. I'm gonna put chat in here somewhere. So let me put it like that. Is that better? I hope it is better now. Though the code is kind of difficult to see now. So what if I put chat like this? Yeah. Anyways, so where is the enum arg? So here is another bogus amogus. Argument is just like a sort of like expression, something that holds an expression. Right, it's kind of difficult to tell. So the arguments are either DataOffset or a specific literal or external or reference to the external and so on and so forth. So I probably want to use missingf in here, and missingf require allocation, right? So we have to pass allocation in here. And now if you encounter bogus, obviously it is in fact unreachable because it's a bogus amogus. Bogus amogus. And let's actually get rid of all of this stuff. And I didn't want to do that, but boom. And this is to do. Missingf, missingno. And in here is going to be this kind of thing. So this is a new line. And I'm going to put that stuff like this. Let's align. Query replace align. Align, I said, mother flipper. All right. So every time we do that, we load an argument. So args items add I, and when I load the argument, so location is this location, then the argument, then the output. Let's fucking go. If I try to compile this shit now, look at that. DataOffset not found, location not found. As far as I know, location is located in Lexa. So we have to import the entirety of the Lexa. Alright, so DataOffset arg is not available as well. Let's put that stuff in here. So autovar, all of that stuff is part of the arg. Let's go. Okay, so there's a bunch of warnings, and then it failed at not being able to load DataOffset. Right, so it was trying to load this entire thing, and then it failed. So as already said, DataOffset, the way we're going to be handling DataOffset, we're going to treat them as unique strings. Right, so we're going to be doing LD string on them. All right, so here's the LD str instruction. So we're going to be doing LD str on DataOffsets, which also means that DataOffsets should be renamed to something like string in the future, right? So, but for now, we're going to keep it as it is. We're going to keep it as it is. So anyway, so go implement it in here. Let's put this stuff in here. So let's do sb append. Right, so this is going to be that LD str. And how do you do that in here? So when you load str, look at that, you have to put that in quotes, which is interesting. So that means we'll have to escape some of this stuff, which is kind of meh, but anyway. So here's the offset, right? So this is the offset. Is it called offset in, yeah, it's not even called, there's no name in here, but let's call it offset. So I need the data section from the compiler. So I'm gonna grab it from here somewhere. Can I use B for OS development? You can use any language for anything because the source code of majority of the languages is open. You can literally hack them to do something. So if B doesn't really support features needed for OS, you can literally implement them. People ported B to calculators, and I never actually supported calculators. People just came in and used their competence and ported all of that shit to calculators. So it's the question more to you, right? So you're asking, can I use B for OS development? I don't know, can you? Do you have the competence to do that? So it's you who has to answer that question, not me. So this is how it works. This is how software engineering works. Anyways, so we have to do, so we have a data. Let's actually go through the compilation errors and stuff like that. So let's be append. All right. Load arg. So data comes in here. So that means we have to get the data as a parameter here as well. Right. So the data const u8. Generate function. So this is also the data const u8. It's a slice that has bytes. When you generate a function, so this is the data, and data, as far as I know, the data is located within the compiler. There we go, it's an array. So we have to take it from the compiler and do the a slice on that. All right, let's go. Okay, seems to be compiled. And already segfaulted? Damn. Haven't even started yet. It's already fucking segfaulted. Bro, I know why. I know why. So let's actually put something like your mom in here. Because I haven't finished it. That's fine, chat. That's fine. Oh yeah, okay. So at least it compiled, but then it errored out in a runtime of mono. Right. So, which is fine, right? So, because we generated bogus, .NET assembly anyway. So what I want to do in here, I want to grab the data section. I want to try to take an offset of it, and I want to take a pointer of this entire thing. And technically, I think that pointer is already basically a string that we can put in here, right? So it's already kind of a string in here. So let's go ahead and try to do that. So does it fail? Does it not fail? Yeah, I have to dereference this entire thing. Okay, so it at least managed to compile. So if I go here, look at that. Yeah, so if you take a look at the original source code, we're trying to do printf on hello world and foobar, and it trying to load strings hello world and foobar from the data section. There should be some sort of escaping in here, first of all. We also need to have some sort of a padding. Let's try to maybe do something like this. Also, new line. All right, let's go. So yeah, so that seems to be working. So LD string, and new line has to be escaped. So we have to do something about that. What can we do? I'm not quite sure. We need to iterate character by character in here. So that's the thing. So what if I actually have something like P is an offset, but it's going to be mutable. So we're going to use it as an iterator within the data section. So in here, while data P is not equal to 0, it is not equal to 0, we're going to actually look at a character in here. And if the character is printable, we're going to just print it as is. And if it's not, we're going to try to escape it. So as far as I know, libc has a function that tells you whether something is printable or not. It's literally called isPrint. So we probably need to forward check if any isPrint. Let's go. Check if any printable characters, including space. Okay, so I feel like we don't have it in our bindings in here. So there's a isDigit. Yeah, there we go. So isPrint. Now we have it in here. So now it is available. So, and if isPrint, if this entire thing is print, what we're gonna do, we're gonna just like print it as a character, sb_append output, just print it as a character to print. Yeah, sure. Now, is there such thing as to print? Is that what you're telling me? You're lying to me, chat. Mods. And if it's not printable, like it depends on how we're gonna be escaping all that stuff. We can just match this entire shit, right? So if this is a new line, yeah, we can do sb_append output, yeah, like this. For the rest of the stuff, we're gonna say it's not supported yet because I don't want to spend time doing anything about that. So this is not supported. That's the thing we want to do. Also, we have to print this around in here, something like that. So this is not new line, but this is something like that. And then in here, this is, yeah, boy, we don't need that. Yeah, so roughly, this is very hackish. This is very hackish, but I mean, it's fine for now. It doesn't even compile. IsPrint not in the scope. Oh, I see what you meant when you said to print. I'm an idiot. I'm sorry. happens. Okay, so X as I32. What if I make it like as I32 in here? Can we do something like that? Yeah. So sPrint, it's not Boolean. So if it's true, right, if it's not equal to 0, that means it is true. Okay, so this one is something like that. And remember, if x is equal to as I32, and we just append it like that. sb_append, what else does it want? Oh yeah, so probably have to do something like that. All right. Oh shit. Aha. I forgot to do p++. Okay, so let's take a look at what it generated. Okay, look at that. New line. So it escaped it. It actually properly escaped it. LDSTR or LDSTR. Let's take a look at the rest of the stuff. Yeah, that seems to be working. Now, what we have to do, we have to call printf. Right, we have to call printf. Let's go ahead and do that. Funcall. So how are we going to be doing all of that stuff? And what's interesting is that in other platforms, we usually have a special functions in Funcall. We have, where is it? Call arg, because this fun is an argument, so that means it can be literally anything. It could be stored on an autovar, it could be external symbol, it could be a string, right? So anything. The user may try to call a string. It's not really supported, but the user may try to do that. So because of that, to call a particular function, you literally have to just do something like call arg. You know, maybe we're going to provide the location of this entire thing. Func and output. So, and then depending on what kind of arg this thing is, it will either compile it or maybe it will error out. Right, we'll see how it goes. Okay, so let's create this function. So you can load arguments, you can call the arguments. So it's public, unsafe. We're gonna have a location just in case. We're gonna have an argument and the mute string builder. print builder. So let's match this entire thing. Where are the args? Let's grab them. Let's fucking grab them. Okay, so this is a bogus, nothing particularly special. I feel like, okay, I can probably copy paste majority of this shit, so I don't really have to construct it from scratch yet again. I really have to. Yeah, that was weird. But anyway, so here's that, and this one is gonna be missing data offset. Missing data offset. I can't spell, chat. What the fuck is going on? I can't spell. So, all right, unsave. fn. What else do you want? Double comma. Can you see the code I'm writing, by the way? Let me actually put the chat somewhere here. You probably can't see shit. All right, so here's the output, and yeah, trying to call an external name. Right, we're trying to call an external name, and if I try to take a look at the enum arg external, yeah, so it's just a name. It is just a name, and if I print that name, I'm pretty sure that specific name is going to be printf, right? So let's do something like printf, like this, and so all of that has to be, by the way, something like that. So this is the name, and this is the name. Right, now let me see. So you can see we're trying to call an external name printf. That's what we're trying to do. So since we don't really have a linker or libc or anything, we can try to literally hard code calling to printf, at least for now. So because our goal is to compile hello world, right? So make hello world work to some extent, at least. So, and yeah, we can do the following thing: strcmp name if the name is printf, and if it is printf, we can literally just call to system console write. Just call to system console write, and that's it. So it's not going to support formatting or anything, but that's not the goal anyway. Our goal is to make a very specific example work as usual, right? So just make a very simple case work, and then you can keep extending it, keep improving it. That's kind of the whole point. So yeah, in here we can maybe log some sort of error, log level error. So here we can say unknown eternal function s. This is going to be, I don't remember, I think I don't have to provide new line. So this is the name, and let's abort in here. I don't think I have a mechanism to unwind this stack in here, so I'm going to just leave it as is. Okay, so let me take a look. So where's my main IL? So this is basically the call that I have to perform in here now. So sb append, So this is going to be new line, but I feel like I need to use a version that doesn't put a new line in here. So I only need to use this one. So this one is going to be 8 spaces, and that's about it. I think that's about it. So I feel like this should already make it work to some extent. So append, so this is output. So what else do we have in here? It worked first try. Wait a second. Yeah, so that's the final compiled program. Believe it or not. Absolute badgering, chat. So this is actually pretty cool, chat. This is absolutely fucking progress. I can call this thing 4 times. This is B code, by the way. This is B code. And now I recompile it one more time. And yeah. So it already works to some extent. It's a very limited support, but it's a support nonetheless. So we just compiled our B hello world to .NET. Right, so here is the .NET executable, right? Here it is. We can take a look at it in the examples. Can you run this executable with the Microsoft tooling, right? So .NET hello exe, right? So you need this runtime thingy-majingy. And I'm pretty sure I can just simply copy paste it from the trash. So trash main runtime, and I have to call it hello world runtime config.json. All right. And now if I try to use, this is the Microsoft.NET. This is the .NET hello underscore world.exe, right? So I'm going to try it, and it also works. So we took our toy language, toy compiled language. We added a very limited support for .NET target. We created an executable, and we run it with Microsoft runtime. The goal of today's stream at least achieved, right? So this is the basis for the new target. I can just commit it and let people and also myself to continue extending it and adding more support for different things. I think it's kind of cool. And what's interesting is that this particular target is kind of cross-platform across operating systems, right? So it potentially may work even on Windows, right? So that's pretty cool. That's pretty cool. I kind of like that. So we can continue working. So I have, yeah, so already spent like 2 hours on this entire thing. Does it run in Wine? I'm not sure. So how Wine reacts to .NET executables? Does it try to run Mono or something? Right. So as far as I know, Mono became part of the Wine project. So that means potentially it may try to use that thing. Nah, it couldn't run it. It actually couldn't run. So Mono can run it separately. Microsoft.NET can run it, but through Wine you can't really do that. Is exe even PE? Yes, it is a PE. Look at that. So MZ, PE, the usual thing, right? So the thing about .NET is that Microsoft's using PE as a container, in a sense that its sections don't contain actual machine code. They contain the .NET bytecode, right? And it's even like visible in here. So file, it recognizes this entire thing. So it's a mono/.NET assembly for MS Windows 2 sections. Right. So that's pretty cool. So I think I also forgot to implement a very important thing for our generator. The result, the result of the execution of the function must be saved into a local variable, right? So because if you take a look, right, so call assigns to an AutoVar like this, right? So we have to take the result of this entire thing and assign it in here. And yeah, this one is rather interesting because this thing doesn't, this in turn doesn't return any function. That's what's funny about all of this. That's what's funny about all of this. Because of that, I feel like what we have to do in a Codegen, since we had coded printf, we have to just push 0, sort of simulating that printf returned a number. Yeah, fake it returning 0. This is exactly what I want to do. Yeah. Spritman knows what him. Sometimes I feel like Spritman just like reads my mind. he's a really experienced dev. He's a really experienced dev. Like he knows exactly what I want to do. All right, so let's try to maybe recompile the entire thing. So how do I? Yeah. So here is my thing. Okay. So now it didn't even compile properly because I need to. Yeah, I need to drop all of these things. But instead of dropping them, by the way, we're going to be saving them to a local variable. Yeah, so there we go. So we're calling it and we're faking returning 0 in here, right? Just for the functions that kind of accept this kind of thing. And then that 0 is going to go away through an assignment to an AutoVar2, to this one. I'm not really sure where AutoVar1 is coming from. I'm really not sure. So it's coming from somewhere, probably from the parameters. I don't remember how we handle parameters. So in the function definition, we have params count and autovars count. Params count is basically the hierarchy of the function. And I do remember that we implemented it so the parameters are then later stored in autovars. So I suppose params count is telling you how many how many arguments you have in here. Like, I don't understand where two autovars are coming from. Like, why do we need two of them when in reality we only need one? I do not quite see it. Right. Where is it coming from? Yeah, it's bizarre. Maybe it's for the arguments. This is strange, man. This is strange. I hope this is not a bug, because it kind of feels like a bug, maybe. So there's two arguments in here, which is argc and argv, right? So command line arguments. And there is an additional thing for saving this, so I expect it to be 3. Wasted one word. Yeah, so it feels like I don't know where it's all coming from. It's bizarre. So how do we do that? How do we do that? Wasted one word, maybe. Let me take a look at x86-64 and generate function. So how many things so stack size is autovars. Okay, autovars include that. Autovars include that. And then, all right, that's very interesting. So that also implies, by the way, if params include the amount of arguments, that implies that we're missing one autovar. I'm kind of missing one autovar. I'll have to think about this one. Okay, so I'm not going to be doing that on the stream, right? So I'm going to do it off screen. A main has no args. So yeah, okay. So this is because I didn't do argc argv. Okay, that explains it. All right. Thank you so much. So that means we're wasted one arg. So that's what happened. We just wasted. Well, okay, wasting it is fine. Wasting all of them is fine. That's totally fine. Okay, so let's actually save stuff somewhere. Can I do st arg? Okay. I really like that the naming of the instructions in .NET is consistent, right? So because I do remember that everything related to args is arg, and you have two operations, ld and st, load and store. So to store an arg, it's basically strg. So it's very easy to remember this kind of stuff. Props to Microsoft for that. Right, so I complain about Microsoft a lot, but I always give the credit when the credit is due, right? So they made some cool things, right? So TypeScript, one of them. The .NET assembly, ilasm, is also kind of cool. I really like it. stlock. What is stlock? I don't really know. So pop value from the stack to local variable. That is not bad, actually. Like, I didn't know about this kind of thing. So pop the top value of the evaluation stack moves into local variable at the index. Okay, let's fucking go. Let's quickly do that. So this is going to be ilasm, and so Funcall, and let's do sb printf output c. So it's going to be 8. stlock. stlock. Yeah. So instead of argument, we needed to do a local variable. You're right. I think I'm just having a little bit of a brain fart. So an index is. Can I just have a name though? Can I just have a name? Why does it have to be? Okay, so I'm gonna just try to do a name. I want to see how C# does that. Yeah, monodis. strlock. Aha. It doesn't use this name directly. What the fuck? And also there's this variant. It's kind of interesting. So I suppose you have just a generic index, which is a longer instruction, right? Which is a longer instruction because it's 2 bytes FE0E, and then the unsigned 16 bits, 2 bytes for the index. So essentially this one 4 bytes. But popping zeros first, second, and third is such a common thing that for them they allocated 1 byte operation. So you don't waste 4 bytes for things that are very common. That is kind of interesting, isn't it? And so there's also variant pop value from the stack into local variable. It's like a short form which is 1 byte. Interesting. So yeah, so there's short form just to save a little bit on the space. So that net will be a B target soon. Yes, it is true. Instruction pops the... I have a feeling like, can I just use names in here instead of the indices? Is that something I can use? I think this is something that I should be able to use because I want to just refer to the names. And this is going to be ZU. And this is going to be just a result, right? So because otherwise, what's the point of assigning names to all of these things if you can't refer to these names? You know what I'm saying? You know what I'm saying? There's no point in doing all that. Okay, let's fucking go. I mean, one more time. It's gonna be run. Oh, it just worked first time, so I was actually correct that you can just assign a name here. Yeah, so look at this code. We generated some ass code, right? So this is the stupidest code I've ever written. Like, it's just like you load, like you put 0 on the stack, you instantly load it to here. But I suppose this is something that should be optimized away by the compiler optimizer or a specific Codegen optimizer, right? So just up to the specific Codegen. All right, so that's pretty cool. Let's try to maybe implement more interesting instructions in here. Specifically, what I want to do, I want to print hello world several times. For instance, I want to say x0 while x++ is less than 10, keep printing this entire thing. So, and what we can try to do, let's take a look at IR. Right, so this is what kind of instructions we need to implement now, right? So we'll need to implement assignment, then, yeah, so this is another assignment, then addition, then comparison, then jumping condition, and so on and so forth. Do we even have time to do all of that stuff? Do we even have time to do all of that stuff? Labels, by the way, implementing labels is super easy because ilasm literally has labels. So can variables get name index kind of names so they're readable in asm? No, because Codegens already lose information about the names of the variables, right? Well, working on a level where all names are already stripped off. So you have to go into high abstraction and forward that information down there. And no, I'm not going to be doing that, sorry. So I suppose the users of the language are not going to be reading generated assembly that very often. It's more for the compiler developers to read all of that stuff. All right, so do I want to go that route? So how many things we have to implement in here? So let's try to compile this entire thing, and as far as I know, it's not gonna fail, right? So it's AutoAssign. Okay, so it is going to fail. So what we have to do, we have to, for each individual instruction failing, we have to stub them with this kind of thing. So AutoAssign is failing. So let's put this stuff in here. Might as well maybe just put that stuff like that. All right, so AutoAssign, next one. So label is rather easy to implement. Maybe I'm going to implement it right now, chat. So let me see. BRS, name OP, label. Yeah, so it's just an index. I'm gonna call it label. And the syntax of the label is literally the same as in any assembly, in fact. So where's my D's? Here, yeah, right. So this is just like labels. Okay, so this is how they look like. And then here, I suppose is be append output C. I'm gonna just do something like that, and this is gonna be LZU. Right, and this is the label. And let's put a new line in here. So there we go. We just implemented labels. We don't have to implement them yet again. So let's take a look at this thing. Binop. Binop is rather interesting. So let's stub it for now. Let's not implement it yet. Also, AutoAssign should be pretty easy as well. AutoAssign should be pretty easy. Jump if not implemented. Okay. This one is interesting. So this is something that we'll have to implement, even though jumping branching in .NET is also relatively easy. It is also relatively easy, nothing particularly special. So jumping to a label. Unconditional jumping. As far as I know, it's actually pretty easy. So let's implement that. JmpLabel. Yeah, it just has a label. And as far as I know, so LDC, so there is a just BR somewhere. Unconditional jump. Yeah, so we can just do BR and you can branch to a target, so it should be easy. So I can even use something like BR, and that's it. So we already implemented this entire stuff. Conditional labels is a little bit more interesting, so yeah, we'll have to do that. All right, so all of that is not failing anymore, so we stubbed all of the things that we need to implement. Okay, look at that. Yeah, so here's the labels and here's the jump into labels and so on and so forth. So for this kind of stuff, I feel like we have to indent them a little bit more stuff in here. Yeah, like that. So let's revert this kind of thing. There we go. Yep, so this is the labels. Though for the labels, I feel like we should actually indent them less so they stand out. So they have to stand out. Look at that. Yeah. So here's the program, and we have a loop which loops like this, as you can see, which loops like this. So this is the rest of the stuff that we have to implement. All of that is auto-assign, which is stupid, by the way. They should not be auto-assigns. So this is a to-do Binop. This one is auto-assign. To-do is JmpIfNotLabel, and I guess that's it. All right, so we only need to implement 3 ops effectively, but this is not really true, right? Because each Binop is different depending on like what we're doing here. We can start with auto-assign, right? We can start with auto-assign because if we implement it, we're gonna instantly implement these 2 things very easily, very easily. Well, yeah. So, but the rest of the stuff in here with like loop is already organized. It already loops indefinitely, right? Because it's actually super easy to implement all of these OPs. Okay, so auto-assign, BRS. What do we have for auto-assign? So this is the index, this is the argument. Okay, ilasm-mono. Auto-assign. So let's put this stuff in here. This is the index and this is the arg. So the first thing we have to do, we have to load the arg like so. We already know how to load the arguments, so we might as well actually copy paste this entire thing in here. So we loaded the argument on the stack. Now we have to save that argument to the index. We can basically use the same thing that we use in here, just stlog, where result is actually index, and there we go, we just implemented this entire thing. It may fail inside of load arg, it may fail inside of it, but the thing itself is already kind of implemented. So let's actually see where it's going to fail now. So args, well, this is just a regular arg. This is just a regular arg, like so. And yep, so we're trying to load a literal. Should be pretty easy as well. Okay, so BRS literal. So and literal. So how do we load literals? I think it's a LDC, right? So it's because it's a constant. It's literally just LDC. And we can use that directly. SB append 8 LDC I8, right? So that's the size of the type, and then we're gonna just put ZU in here, and this one has to be output C literal, and yeah, I think that is working. Okay, so I think we need to put like a new stuff in here. All right. Okay, so that's pretty cool. Now it is trying to load AutoVar. Tries to load AutoVar. So yeah, it's basically LD lock. So let's go ahead and see AutoVar. This is index. So let me copy paste the whole thing in here. It's actually going much smoother than at the beginning of the stream, right? So because we already have all of the machinery set up, so we're just like piling more and more instructions on top. So loading a local, and it's going to be just basically like that. So v underscore. I think that should be enough, basically, hopefully. Let me double check how ldlock works. So load variable onto the stack. Okay, cool. So let's try to compile this entire thing. And literal, not in the scope, because it's an index. Yeah. That's cool. All right, let's take a look at the generated assembly. Okay, so that seems to be working. That's pretty cool. So we did all that stuff. We loaded v1 and saved it to v2. Kind of a useless operation, but so that is what our compiler generated, right? So we're just a backend. We're just following instruction, right? So you take 0, you store that into local variable 1, then you load this from the local variables and store it into v1, right? So that's basically how it works. So thank you so much for the sub, FGSF. Just following orders, MonkOS, yeah, that's what we do. Yeah, so what's going to be the next operation that we have to implement? So maybe Binop. We can try to do Binop. So let's go ahead and do that. Binop. Where's le Binop? BRS enum OP. So Binop. So that's the things we have in here. I want you to copy only this thing. So here is the Binop itself. The index is basically where we store the result, left-hand side and right-hand side. Left-hand side and right-hand side, relatively easy to implement. We just do that, LHS, RHS, there we go, we loaded all of them onto the stack. And then, depending on the Binop itself, we are supposed to perform different kind of operations on this entire stuff. Yeah, so, and if I take a look at the enum Binop, this is the operations that we should be able to support. So, and yeah, that actually makes it super easy to implement. What the fuck? So Binop like this, very similar to UXN, which is also a stack machine. Yeah, that's understandable. I mean, yeah. Surprise, surprise. Am I right? Surprise, surprise. Missing OP location. We might as well grab this entire thing, put it in here, and new line. So it's going to be 14, align, stuff like that. All right, so we got these kind of things. And now we also need to store the argument, right? So we have to do st lock Where is the st-lock? I don't see. We lost it. I didn't see st. Yeah, there we go. So let's put it in here, and this is just the index, and that's it, right? So it should only fail now here and on one of these binops. We'll need to implement only 2 binops in here. So yeah, so currently what we're doing is that we trying to make a compiler from B programming language to .NET executable. So we're trying to compile this kind of thing to .NET executable. And we're being successful, by the way, at that. We're being successful. So let's fucking go. Missing, so it doesn't know what is a binop. Binop. So, and it is, it's a macro. All right, cool. So plus doesn't work, and the implementation should go there. Okay, so LDC. Guess how they call operation that adds to numbers. Well, so that just means that the only thing we have to do in here is to just emit that operation, believe it or not. Absolute budgeting, I know. Okay, so this is going to be something. What's the indentation? It's actually 8. Okay. Add. All right, so we already did that. And what else do we have in here? Output, excuse me. All right, so mismatched type. Okay, cool. So now it's complaining about less. And less. All right, so LDC. Let's actually try to find. I wonder if it's even possible to do that. Do this kind of comparisons. Damn, because it's probably branching on condition rather than doing this kind of comparisons. So yikes. Compare equal, compare greater than. Maybe one of these. Maybe one of these. We can always just like try to see what is going on in there. Right, let's go into the trash, experimental trash. Right, so let's do monadies. Main C, S. And one of the things I want to do is, can I just save A less than B? Right, so can I do something like that? So here is that. CLT. Oh, there is literally CLT. CLT. Compare. Oh. Okay. So it's literally contains that. Okay. So let's go here and yeah, that was easier than expected. It's actually kind of cool that at any point you can just like write some C# code and inspect what it's generating. Right, really convenient for this kind of stuff. I think it is really convenient, chat. Okay, so let's take a look at the at what got generated. Okay. So the only instruction that is left to implement in here is this one. But apart from that, yeah. So we generated some stuff, and this thing is supposed to actually, you know, print "Hello World" 10 times. That's kind of the idea in here. So only one instruction is left. Only one instruction is left. Alright, so it's kind of cool that it's kind of like a program is emerging, right, out of just like you implement some instruction and just like emerging out of nowhere. Kind of cool. Alright, so let me see. JmpIfNotLabel. JmpIfNotLabel. So here it is, JmpIfNotLabel. Let's put it in here. So we have a label and we have an argument. The way we're gonna work with all of that, obviously we probably just want to load the argument. We just want to load the argument into this entire thing. So We load it, and we now want to see if this thing is equal to 0 or not. All right, so we can branch, like branch instructions. What kind of branch instructions do we have? Okay, so this one is interesting. Branch on not equal. That's kind of cool. Yeah. So the beginning instruction transfers control to target if value is not equal to value 2 when compared unsigned for integers or unordered for floating point values. Value 1 and value 2. Okay. So that means we have to push something in there. So load C. Right. So I guess not equal, not label. So jump if value is equal to 0 because it's false. Yes. Oh, there's a BR false, really? Oh, fuck. Okay. Oh, that's actually cool. Thank you. Thank you so much. Thank you. Like, I'm not familiar with .NET, so I'm implementing all of that basically blind. So that's actually kind of cool that it has that bare false. All right, so that should be it. Surprisingly. Label if not, this is OP. Okay, so there's a bunch of warnings in here. Unused variable, yeah. Because we have to provide the target, right? So the target is ZU and the label. So this is where we're jumping. Compiles. Actually compiles. All right, so this is the final program, and it's supposed to print hello world 10 times. It's kind of unoptimal, but that's fine. That's kind of expected at this point. So here is we do a bunch of stuff, all right? So addition and stuff like that, and BR false. So this means this is the condition of a while loop, right? Does it run? We're gonna run it soon. Don't worry about it. So here's the while loop. And here we have a relatively complex condition, which also modifies the state of the variable and stuff like that. So this entire expression got compiled down to this entire thing. Right, this entire thing is just this expression. Right, it automatically checks and also modifies the counter. So that's kind of cool. So, and I suppose this is the body, right? So this is the entirety of the body. And here at the end, we're jumping back to the condition that checks and modifies the counter. Then we print again, then we jump back, and so on and so forth. So that's basically how it is compiled. Theoretically, we don't know if it works or not. So let's go ahead and add the run flag, right? And see if it's going to go into infinite loop or it's going to runtime error or something like that. It runtime errored. That's very interesting. Oh boy. So I wonder what the fuck is going on. All right, let's fucking go. So can we simplify this entire thing somehow? Can we simplify this entire thing? We can just try to maybe comment out. Let's actually have like a while loop, which is much simpler. All right, so strlog2. So it couldn't store something in one of the stlogs. Strlog version 3. Did I do any fucky-wucky? That's a real question. So probably type a mismatch, some ops return I32. Maybe that's what's going on in here. I wonder which ones though. Just give me a second. I'm gonna pour some water and I'm gonna be back. Yeah, we need to figure it out. We're pretty close though. We're pretty close. So Was that C# bytecode? Yes, it is in fact a C# bytecode. We're generating bytecode from this language, right? So we have a language which is kind of a recreation of original B programming language, the predecessor to C, and we're trying to compile to all sorts of different targets, one of them being .NET, right? So while also doing all that on Linux, so just like for shits and giggles, right? For shits and giggles. Excuse me. Okay, so can I continue simplifying the code just to find where we have some problems? Let me see. So just like, can you assign 0 to x? Okay, you can. Can I then do x++? Is that something I can do? Okay, that's pretty cool. Can I then compare this entire thing to 10? Can I do that? I can't. I actually expect that maybe it has something to do with Boolean, because CLT returns a Boolean and they're probably not compatible. So that's probably what's going on here. So let's actually focus on that. CLT. CLT. So the CLT instruction compares value 1 and value 2. Value 1, okay, can you see that? Okay, right. Value 1 and value 2. If value 1 is strictly less than value 2, then 1 over type i32. Fuck you, Letterman. Fuck you. How do you convert 32 to 64? Does anybody know? Of type I, yeah. So, fuck. Fuck you. Okay, CLT. Probably add 0 in front, multiply by 2. You guys are funny. Extend, maybe. There should be something like conv. Aha. Convert the value on top of the stack to the type specified in the opcode. Okay, so I suppose I can do conv i8. All right. Okay, let's fucking go. Conv i8. Sodium likes assembly. Well, it's kind of difficult. I like programming. Let's put it this way. I like programming computers. Computers primarily understand assembly. So that's how it goes. That's the dynamic of my relationships with assembly. That makes any sense. Okay, so now I should be able to try to do something like that. Okay, chat, look. Let's count. 10 lines of hello worlds. Absolute budget. Ah, I'm so sorry if it was too loud. Anyways, so we know how to compile this kind of shit, so which is kind of cool, I guess. It's kind of cool. We can now even have nested stuff in here because it's basically the same instructions, right? It is basically the same instructions, and every like 10 lines in here, we can even probably do something like that. And all of that is a valid program that is in fact compilable to .NET. So it's kind of interesting how just by implementing few operations through a combinatorial explosion, you can actually write a very complex program now. You can now solve, basically, I think FizzBuzz is more or less compilable. In fact, we already have FizzBuzz. The only problem we have in here is that this thing, right? So FizzBuzz is kind of difficult to implement like that. So we need to be able to print numbers. Right, let's try to compile this specific program, right? So here's the FizzBuzz. Okay, so is FizzBuzz even compilable? FizzBuzz. All right, so less equal. Okay. So do you have CLE? CLT? I suppose we need something like CGT, and negate it. Right. So that's probably what we have to do to implement, you know, less not equal. So try to do that. C GT, right? CGT. And how then I negate that? So do you have not of some sort? A, B, C, D. Not. Bitwise complement. Okay. Not. Like this. So this is less equal. Is that a good one? Hopefully. All right. Mod. Back. All right. So let's go ahead and implement that. So CLT. Do we have? I don't see mod though. So there should be something like a division. It's probably rem. Rem. It's probably rem. Yeah. It's rem. Where is rem? Remainder when divided. Okay. So. Are we gonna implement the entirety of the .NET target today? Okay. Binop equal. CQE or CLT CEQ. Okay, so this should be pretty easy. CEQ and convert to 64. All right, anything else? Bit or. Okay. I do remember having or. Yeah, here's the bitwise or. Man, why is it so fucking easy? What the fuck? I do not believe Microsoft made that. I do not believe that Microsoft made that. Well, there is something. Sometimes, like among the Microsoft slop, there's some small little gems scattered across the slope. How the fuck does that happen? What the fuck is this company? Oh, they hired the Delphin. Yeah, okay, so that's probably the reason. It's just like, I can't believe that Microsoft made this thing, right? So it's just like, it makes sense. Like, you don't expect this kind of shit usually from Microsoft, but sometimes they have a stroke of genius. They hire in a right guy or girl, and that just works for them. Anyways, okay, so runtime error. Though, there was something interesting in here. Yeah, we fucked up somewhere. We fucked up somewhere, and so it was trying to call something. Yeah, so let's actually see. I have a feeling that maybe this is some... Yeah, so it's probably because of this. It's probably because of this. So let's actually temporarily disable this specific thing. Right, or let's put it this way. I'm gonna put printf to do number. Yeah, and this is the new line and whatnot. Okay, that is funny, cause yeah, something weird is going on. It kind of worked, but at the same time, it kind of didn't. Some of the operations didn't like work out properly. I wonder what exactly happened. Maybe because of this stuff. I have to explicitly. No, I don't think so. No, it goes indefinitely. It goes indefinitely. So what we want to do in here probably, maybe we want to do something like print n, because in lib standard library is supposed to supply this kind of function, print n number and base. Maybe this is something that we could have used in here. Base is going to be 10. Right. So, and to implement this specific function, we could use the stuff from, yeah, from kbman. So print n. Yeah, so that's the implementation we have. It uses putchar. That also means we have to implement putchar though. Right, we have to implement putchar. How difficult it is to implement? Yeah, we'll see. So let me put this stuff. Ew, tabs, disgusting. So can I replace tab with 1, 2, 3, 4? Boom. Okay, so this is interesting. So is it going to compile or not? Let's see. Let's fucking go. All right, so diff is not implemented. All right. Should be easy. Famous last words. Emacs, fucking Emacs. All right, unknown function print n, which is kind of funny. Yeah, so now what we have to do, we have to implement the funcalls, right? So if it's something unknown, let's try to call a local function. Right, let's try to call a local function somehow. It feels like it's gonna go into some sort of rabbit hole. I also need to implement the arguments in here, so I don't want to go there. Honestly, don't want to go there. So, okay, listen. So let's do the following thing. Let's also hardcode this entire stuff for the print n. So how are we going to be doing all of that? So this is print n. Okay, so to do unhardcode all these externs. So this is for myself. So in that specific case, I think we only need this stuff. So this is a printn, and the function that we're going to be calling is going to be write, but int 64. Right. And I suppose we also need to, well, I should have not removed this thing. I should have just created an else in here. And this is 0. Right, something like that, you know? Something like that. Okay. Unknown printf. I could not find printf. Let's print n. I got that. All right. So it kind of compiled, but it went over this entire stuff. It went over 100. But overall, I think it did the thing. Negative versus not. You think it's negative versus not? Maybe that's what it was. But I would expect it to. Okay, let's try negative then. It didn't even run. It has to be some sort of a not. CLT. So let me. So less equal, great, not greater than, not greater than. I have a feeling that maybe we just handle this kind of stuff a little bit incorrectly, but it's kind of difficult to tell. Yeah, bitwise not makes one into, yeah, no. Is there a logical not? Negation. Negation is a minus. It's not what you think. So it's a tooth complement. So negation instruction negates value and pushes the result onto the stack. The return type is the same as the operand. Okay, so I have an idea. So instead of not, let's maybe push LDI8 0. Right, so actually, yeah. So if it is 1, we want to make it a 0. Can I swap? Do you have something like swap? Can you swap the arguments? No, you can't swap the arguments. Mm-hmm. Yeah, that's a good one. LD. Well, in that case, it's 4 because this entire thing is 32 bits. Then not equal to 0, and we convert it to I8. Yeah, it worked. Thank you. Thanks. So that's a good idea, actually. That's a good idea. So FizzBuzz, we just compile. Spent 3 hours and we managed to compile FizzBuzz to .NET. So did I pass an average tech interview? So FizzBuzz is claimed to be the programmer's filter, right? So I spent 3 hours and I compiled FizzBuzz to a new platform. So UXN doesn't have less than or equal. UXN doesn't have a lot of things, actually. UXN doesn't have a lot of things. So yeah, that's kind of cool, right? So I honestly didn't expect that I'm gonna achieve this success on today's stream, right? So it's a rather complex program. It's a rather complex program. So I just implemented the required operations and it just worked. Like, what the fuck? This feels like magic, honestly. When you have a fully working compiler, and you add in a new target, it really feels like magic, right? So because you just have to provide what specific operations of intermediate representation means, and everything else is just works. Like, what the fuck? Yeah. So that's it, the .NET edit to the roster. Yeah, one of the things we can try to do, by the way, we can try to maybe run the tests and see how many tests are failing, probably all of them. Right, so let me actually see. Let's recompile the entirety of the thing one more time. And let's just literally, run the test. Yeah, let's fucking go. Yeah, so something panicked. Not yet. Yeah, so we don't have a runner for this entire stuff. We don't have a runner, though we can actually relatively easy to implement it. Nah, so we have to spend some time because we need to organize the redirection of the output, so it's too much effort for today's session. Don't want to do that. Right, so it's for the another time, but there you go. So here's the FizzBuzz, and the executable for the FizzBuzz, here it is. Here is the FizzBuzz executable. Right, so let's take a look at the file. Yeah, it is PE32 executable mono.NET assembly. So let's actually copy paste this entire thing to FizzBuzz, and let's try to run this specific FizzBuzz with the Microsoft's runtime. So .NET, right? .NET FizzBuzz.exe. And Microsoft's runtime also works. We can even compare the, that's actually relatively fast. So 0.51 milliseconds. We can compare that with maybe Mono. This is Mono. This is Mono. Mono is fucking A. I already said enough about Microsoft runtime. What do you expect from Microsoft? I don't know. After my first .NET .NET video, all the Microsoft normies were shitting on me because I said bad things about .NET, but I don't even have to say anything, bro. I don't even have to say anything. It's just like JSON parse time waste, probably. Could be that actually. Could be fucking that. No, Zozin, this is unfair comparison. Do the proper benchmark. I can already fucking hear them. Does rule 110 compile? This is a good question, actually. So let's see. A malloc, motherfucking malloc. And it's kind of difficult because we either have to get rid of the malloc or we have to replace it with global arrays. Neither of these things are supported by the target yet. So no, it's too much effort right now because I'm already kind of wrapping up. But yeah, so it should be easy to actually add support for rule 110. Okay, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all in the next recreation programming session with Mr. Azuzin. I love you all. Mwah.